Test, test. Test, test, test. Test, test. Test, test, test. How's my volume? Seems like it's doing.
How about now? Oh, now it's much louder. How about now? That's a little bit better. Okay. We seem to be live. All right. So here's this. All right. It looks like we're streaming. Excellent. Okay, I'm getting the website and stuff updated to say that I'm live. Oh, I should. I probably want that still open. While I'm doing that, I'm waiting for that to go because it's going a little slow. We'll just emphasize abolish ICE, abolish ICE, abolish ICE. I'm going to say it every time I stream. I have the tiniest of platforms, and it seems unconscionable to not use it to talk about the jackboots in our streets, right? It's unacceptable anywhere, and it's completely bewildering in America. It doesn't make sense to me how anybody can support it. So we say abolish it. Do what we can to work towards it. It looks like the midterms are not going to be kind to conservatives. So I think we might be headed towards sort of regained sanity, but the U.S. has lost a lot that we won't recover. Our standing in the world. Yeah, it's crazy. but today we're here to do some math. Um, I don't have any math questions. So today I wanted to, no, the stream has started. So let's just put this over here for the next day. We're going to work on some Euler project today. I'm still getting the website updated though. It's going really slow. Sorry. I do have I'm learning how to make WordPress plugins. And I have one that I think is going to make updating the stuff I need to update on my site a little bit easier. So I just need to get it installed. Here it comes. Euler's tutor is live. Yeah, doesn't look like there's questions. So once I get this site updated, we will move into Euler project stuff. We're still on question 0. But my hope is to get question 0 submitted today and actually get into Project Euler proper. And then I'm going to be ending, I don't know, 11:45, 11:50, something like that. Because I have a student at noon. Anybody who ends up watching this, I do offer one-on-one tutoring. My advertised rate that you would see on, say, my website is $50 per hour, but that is negotiable to fit students and families' budgets. I often have students in my roster that I am tutoring for a discounted rate, and some students that I'm tutoring for free. So if you need tutoring, but $50 an hour is outside your budget, you should still reach out to me. I am more interested in helping you with math than I am in making my full hourly rate with every single student, right? I have enough students who are like, yeah, I can afford $50 an hour. That it allows me to be flexible with the people who can't afford it. Okay. I think, there we go. Yep, website is now updated. Sorry that took a minute. My website builder was just being so slow. Okay. Let's. Here on my face. I need a haircut. My hair is getting out of control. There's just so much of it. Look at all this, you guys. Look at all that hair. All right. So, last time we worked on Euler project, we were working on problem 0, which is just like the registration problem. Like you have to, it's essentially their like the equivalent of like a CAPTCHA, right? So to even register, you have to answer a question. That's actually, for the type of problems that are in Euler project, this is probably the easiest possible one. And so this is what we're trying to do. So let's remind ourselves, we're talking about perfect square numbers, which is just a number like 25 that is some other whole number squared. 5 squared is 25, 16 is 4 squared, 36 is 6 squared, 100 is 10 squared, right? So 16, 25, 36, 100, those are perfect square numbers, right? Or just square numbers. And the first 5 square numbers, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And if you add up just the odd squares, the first one, the third one, the fifth one, or the squares of the odd numbers is another way to say that. If you look at just those ones and add them together, for the first 5, you get 35. But what we want is among the first 498,000, oops, I didn't realize that wasn't locked in place. Among the first 498,000 square numbers, so all of the 498,000, what is the sum of just the odds? Which, okay, so initial notes, odd squares are the result of squaring odd numbers. So we just need the first 498,000, odd numbers. So our initial list is just going to be the first 490 or the first 249,000 odd numbers, right? So we just need to go up to 498,000, except we won't use 498,000 because it's even. So these are sort of some notes about this. We're just looking at odd numbers. If we take all the odd numbers that we need to square, we can just start there. So what we want is our limit value, which in our case is 498,000. But a reminder, the way I want to approach these problems is to make a generic solution, right? So we're going to solve it for 498,000, but I also want to be able to just enter a different number and have it give me that. So the first million, among the first million square numbers, what is the sum of the odd squares? Among the first 50, right? Just enter any number I want, partially because this number here changes for problem 0. For the rest of the problems, the problem is static. It's the same for everybody. But for problem 0, they change this part, the 498,000, they change that periodically so that it's a good CAPTCHA, right? So you have to solve it fresh. But if I just make a generic algorithm, a generic process that I can tell it what the limit number is, then it'll work for anything, right? So we get the limit value as an input. We make a list of all odd numbers up to the limit, inclusive, right? If this was 498,001 square numbers, then we'd want that last one. So that's why it's inclusive. In our case, it's even, so we do get to ignore it. And then we take that list, that huge list of numbers, and we make a new list by squaring each number in the first list. So we'll square 1 and get 1 and put it in a new list. We'll get square 3 and get 9 and put it in a new list. Square 5 and get 25, put it in a new list, so on and so forth. And then once we have that new list, we just go through and add all the numbers together. And then we output that. We output that sum. Okay, so here's what I want to do. Oh, okay, so sorry, screen changed a little bit there. So here are our notes. Is that readable? It is readable. Okay, here are our notes. Here over here, this is Python idle. I in the previous Euler project video, I showed you all how to get access to how to install Python on your machine, how to get access to this idle shell for using Python. You don't need idle shell. You can just write Python code in a file and run it. And we'll talk about that at some point. I wanted to do this because it's straightforward and it makes it accessible. There are also online, like there used to be, I don't know how good this is anymore, but when I was teaching computer programming in middle school, I used repl.it, Replit. Oh no, it's all AI-ified. That sucks. Like pricing, this used to be a free like learning tool. Upload a file. No coding needed. No, I want to code. That's the thing, is I want to code. Damn it. Okay. Free online Python interpreter. So Python is a scripting language, so it is interpreted. It's not a compiled language. It's not compiled. Even though this says online Python compiler, parenthetical interpreter. W3 schools is in general pretty good, or at least they're good for reference. I use them all the time. With our online Python compiler, you can edit Python code and view the result in your browser. It's Python school. Anyway, all I'm trying to do is find some like good online options for you. If you just wanted to do this in your browser, follow along in your browser. Ugh. Everything's going very slow, and I apologize. I'm streaming from my older computer just because it's set up the best for doing this, but streaming does bog it down. Okay. Well, that is. There are free online ones, but there's so much AI stuff anymore that's infecting everything, and just people pushing like, you don't need to learn to program, you just need to learn how to use AI. That's not true. If you don't learn how to program, you don't learn the underlying skills, and then you're just limited to what the AI can accomplish, which is a lot, but you also are more limited in how you can interact with the AI, so it's harder to get it to do the stuff you want. Suffice it to say, AI is not going to free us from the burden of having to learn things and know things. I think it's an enjoyable burden, honestly. I like learning things and knowing things. But okay, so we are in a blank or a fresh Python shell. This isn't the only way to do this, but it's the way I want to do this initially. We will talk about writing like script files at some point in this process, because these problems are going to get more complicated and there's going to have to be more moving parts. But for now, this is a really straightforward one. We should be able to do it just directly in the interactive interpreter here. And I showed this off last time. This is essentially, this is just, this is live code. This is live code that, so I can just write 2 plus 3, that tells me 5. I could say x equals 10, and then I could say 5 plus x, and it should say 15, because x is 10. There we go. If I just say x, it tells me 10. Oops, I hit enter a bunch. I did not find a way to clear this shell. Unfortunately. But that's okay. Yeah, we can. That's frustrating. Why is it doing that? I can restart the shell, but it just does that and just gets rid of everything up above, but it doesn't actually like scroll it out of the way, which is crazy frustrating, which means we're going to be down here at the bottom at some point, and I hate that. I hate when they don't have like over scroll and stuff like that. Anyway, so here's what I'm going to do. I'm just going to restart it. That'll be the way to do this, I think. Boom. Okay. So here's what we want. So I'm going to make a new variable called limit. And right now, so this will run quickly. We're just going to do, we're going to say our limit is 5. So we can test it with their little test case here. And we should get 35. And then we can test it with more stuff and see if we increase that limit, because we can always change the limit. Okay. So there's our limit value as input. We're not actually making something that has input right now, but there it is. It's established, and so we can use it anytime we want. You can't go back up here and edit, like in like Desmos, how you can edit stuff up above and it'll just redo everything down below. But that's okay, because we can nice. We can just grab stuff from up above, right, and bring it down to our current line of execution here. So the steps I outlined here are not the most efficient way to do this, but it is the most direct, straightforward way. So we're going to do it that way. And then as we move on, we will talk about efficiencies and things like that. But I want to get us started here, right? So make a list of all odd numbers. So I'm just going to say odd numbers. Equals. And so here's what we're going to do. Python has this built-in function called range. And now if I do that, you can see it pops up this little thing that tells me how to use range. I can specify a start value, a stop value, and a step value. So I want to start at 1. I want to stop at limit. I think range is exclusive. It's going to include the 1, but it's not going to include the limit. So I'm going to do limit plus 1. And then the step is step size 2. So what that means is it's going to start with 1. It's going to add 2 to it until it gets to this limit value. If it hits the limit value or gets above it, it will stop and it won't put that new number into the list. As soon as it hits it or goes above it, whatever new number it's at, it's like, okay, that one doesn't go in this list. range. I want to pull up that, yeah. And it returns a range object. Huh. I think that's fine. I think a range object is the same as a list, or at least for our purposes, is the same as a list. Okay. And now, so now I hit enter, and it's in there. But if we want to see what's in it, we can just type odd numbers. Check it out. Oh, fascinating. 1, 6, and 2. Okay. How do we? So here, I'm letting you know how programming works. You Google stuff. So we want Python range to list. Okay, we can just call it. We can just tell it to make it a list. Okay. So here's what we're gonna do. We're gonna do odd number. Actually, here's how we do this. Easier. We scroll up, grab this. Where our cursor, you can see our cursor is on this line. So I'm gonna hit enter. It brings it down there, but now it's editable. I'm gonna do this. I'm gonna say list. Okay. So this range is gonna return. This is getting into a little bit into the nitty gritty of the Python language. But this range, it will construct the list we need, but it's not the right type of data yet. So this will convert it into an ordered list. 1, 1, 3, 5, 7, right? So let's do that. And now let's type odd numbers again to see what we got. There we go, 1, 3, 5. That's exactly what we wanted, right? Okay, perfect. And these brackets right here tell us it's a list object. Okay, I'll close that. We're gonna end up Googling lots and lots of stuff. I'm gonna keep a new tab open just for that. Okay, so we have our limit value. We have a list of all the odd numbers up to our limit value, right? I printed this out to test. That's why I didn't want to make the limit a super high number just yet. So we want to make a new list by squaring each number in the first list. So we can use in Python list comprehension. So the reason I'm looking stuff up is because programming languages have really specific syntaxes. You have to type stuff the right way. Python has a really nice syntax. It reads as like, it doesn't use a lot of like esoteric or weird sort of symbols or abbreviations. Stuff is pretty straightforward, which is why I like Python. Okay, is this all I wanted? Is just 4x? Oh, but we can't. Okay, this is what I wanted. I wanted to do a new list like this. Okay, so that's what we want. So now we have odd squares. Notice the underscore. You can't put spaces in your variable names, but you can call them anything you want, so long as they don't start with a number and don't have spaces, and other special characters, but you can't have underscores. Okay, so here's what I'm going to do. The brackets here is a shorthand. Excuse me, I'm so sorry. For this, it's telling us we want this as a list. So we're going to go new list equals expression for item. Oh, okay. So what we want to do is we want to do x squared, and we don't have to call it x. We can call it whatever we want. But whatever the number in there is squared. So we want to do x squared for x in odd numbers. So what this is going to do is it's going to create a new variable called x, and what the for is going to do is it's going to do the same thing for every x, every number in this loop. So it's going to square each of them, right? And it's going to spit it back out. And what we're doing by putting it in these brackets is telling it, okay, each of those numbers, hold on to them and put them in a list. Numbers. And we don't have to have, it looks like we don't have to have this if statement. That's an optional condition. So we could just make a range of all numbers up to our limit, and instead of just getting, and have it essentially have it skip over the even numbers. But like, then we're storing all the even numbers and we don't need to do that. So that's just a different way to do it. Okay, so odd squares equals that. And now if we type odd squares, we should get 1, 9, and 25. So a list like this, but 1, 9, and 25. No! Oh, you know why it is? This right here, that's not the notation for squaring something. Duh. So we're going to go up here. We're going to do that. We're going to bring it back down. We're going to go here. We expect that up caret to be exponent. It's not. It's a double multiply. I don't know why. I'm sure there's a reason, but honestly, that up caret I think is used for bitwise. It's for bitwise arithmetic. You don't need to worry about what that is. But suffice it to say, we need this. So we'll do that, and now we'll do odd squares, and it should be 1, 9, 25. There we go. So notice, I want to point out a few things. Notice how I haven't done everything exactly right the first time, right? Python is a lot of, if I programmed in Python every single day, which lately I have some projects going on where I'm getting close to that, I wouldn't have to look up as much, and I wouldn't forget stuff like this as much if I'm using those features of Python. But the thing is, I haven't done mathy Python in a really long time. Well, not a really long time, but it's been a little bit since I've done math-focused Python. I've been doing a lot of like file IO Python, which uses whole different parts of Python. And so even if you're using a language every single day, there's still parts of it you might need to look up because you don't use those parts every day, and that's totally okay. Programming offline is hard because you can't look stuff up. Programming online, super easy because you can just look stuff up. I really like this W3 Schools. It has very straightforward and concise sort of information about how like you can look at this. Look at all these properties of the Python language, right? You can just look stuff up. And it's very concise. Sometimes a little too concise. Sometimes I do need a little bit more detail and I have to go someplace else. But for the most part, W3 Schools will get me there. Okay. So there we go. What have we done so far? We've got the limit value. We have a list of odd numbers. We have a list of square numbers. Now we need to find the sum of those square numbers. I'm pretty sure Python has a built-in sum function. Let's see. Yeah, sum function right here. So another W3 Schools link. There is a sum function. That's awesome. So sum, S-U-M, as you might remember, just means to add is the result of addition. So if we say sum, and we say the sum of the odd squares, we should get 35, just like in the little sample right here. And there it is. There's that. And now if I go up here and rerun the sum of the odd squares, notice we still get 35 because changing this doesn't rerun any of these other lines, right? So odd number is still 1, 3, and 5. Odd squares is still 1, 9, and 25. So what I have to do now that I've changed this, I have to rerun all of those other commands. So we'll do that. We can see odd numbers. is now 1, 3, 5, 7, and 9. What was that? 4, 9, 16, 25. Right, we're not adding those together because now we need to go up and we need to do odd squares. There we go. 1, 9, 25, 49, 81. So that's 50, 75 plus 90 is 165. We should get 165 when we do that. There we go. So it appears to be working, but notice I have to go up and grab those lines of code, rerun them, get everything up to date. This is not the most efficient way to do this. We will talk about more efficient ways to do stuff like this, but it does work, right? So here's what we need to do now. Now, I need to go up. So now that we've tested this and we can see it's working for small lists, now we go limit, and we go 498, 1, 2, 3, 498,000. And I go and grab the odd numbers. We can check on it, but it's going to be long. Let's see what it does, though. It's thinking. It's a lot of numbers. Squeeze text, 21,280 lines, right? And so idle here, instead of creating all 21,000 of those lines, it squeezed them here. So they are all here. I want to see what happens if I click this. It might crash idle and we might have to redo a lot of this, but that's totally okay. In fact, though, actually, hold on, let's do. I'm going to copy all of this right here just so I have it in case this crashes. So right, this is why. So we could do these ones without a computer program, right? We could find the first 3, the first 5 odd numbers, add them, square them, add them together on our own in our heads. Pretty straightforward. Oh, you have to double click. It's very long. Extending it would make idle slow or understand. It is recommended to view or copy the output instead. Oh, okay. So we don't want to do that. Right click for more options. So what if I go view? What does that do? Oh, it has a squeezed viewer. Oh, this is nice. Look at it. Here we go. See, okay. They're all odd numbers. 1, 3, 5, 9, 7, 9. Yeah. Okay, and that's the 497,999. The next number will be 498,000, which is even, so we don't have it. Okay, so I should be able to close that. Oh, it is trying to do something. It's a lot of data, right? And it has slowed it down. I need to let it close this. I was hoping the viewer would not get bogged down quite as much. I was hoping it was, and it is probably optimized for this, but one, my computer's going really slow. There we go. Okay, so as we can see, the odd numbers are there. So now what we want to do is go up and do our odd squares. Do the same thing. I'm curious how long this is going to take. Because it's not displaying anything, it's just running the calculation, it probably won't take very long, but it might take like a second or two. Yeah, there we go. You can see it. You barely saw it. This sort of flashed for a second and then became an input. It thought for not even a full second. So 250,000 numbers, it found the squares of them in a fraction of a second, right? Now, if it had to display them, it would take it longer. That's more intensive. Okay, but now that we have those squares, we're not going to. I'm not going to display them. When I did odd numbers, we saw that it would do them, so I believe that they're there. So I'm going to do sum, and again, this might actually take longer than finding the squares, but it might take just as long. We're going to enter. See that? Super quick. We just added together, and some of those squares are gargantuan numbers, right? 499 or 497,999 squared, right? If we do 497,999 times 497,999, that's a gargantuan number, right? So a ton of the numbers in the list are this big, and there's a quarter of a million of them, roughly. And we added them to, we found the total of all of them in a fraction of a second, right? Okay, so we're gonna grab this number right here. That's our number. However, this 498,000 has probably changed. So let's go here. I'm gonna close these. Let's go to Project Euler. It's projecteuler.net. Got it. Okay, so we're gonna go to register because that's where this problem 0 is. And look, it's the first 530,000, right? So we need to go back up here. We need to get our limit, change our limit to 530,000. Boom. Get the odd numbers, get the odd squares, and finally get the sum. All right, there's our number. So I'm going to copy that. I'm going to paste it there. I'm going to put this here, 82553. And we're going to check. Congratulations, the answer you gave is correct. You may now complete registration. Here's kind of what I want to do with these. Is just grab them and put them in the Miro board. So here, I'm gonna grab all of this. Duplicate it over to today's notes. And paste this to show that we were successful. And now this stuff that it lives here in this shell, when I close the shell, it's gone. The work we did here, how we figured this out is gone. We have our notes, right? So we could always recreate it. And this one isn't a big deal. We didn't really get anything useful from this that we'll be reusing. So it's fine to let this disappear. And now we can complete registration. So let me do that really quick. In fact, I'm going to, while I finish registration, I'm going to stop sharing. Let me get the credentials I've already created for this, but haven't actually signed up. Okay, there's that. So our username is going to be the calculus tutor. We'll call it Ryan, the calculus tutor. Let's see if the calculus tutor is available. Let me adjust my notes here. Okay. Get our password in here. Okay. There we go. Okay, let's share the screen again now that I'm in here. Yes, save my password. Oh, no, not window, screen. There we go. Okay. So this is, once you're in, this is what Project Euler looks like. It is literally a list of their problems. And I think I more or less just want to go through these in order. I would love to complete the first 100 Euler project problems. There are nearly 1,000. Any illusions about doing all of them, right? Like maybe over the course of my lifetime, but like over the next year or so, I would love to get through the first 100. I am the calculus tutor on here. Apparently you can have friends. Nice. There's my friend key. If you want to, if you're on here and you want to add me, progress. Oh wow. Oh wow. Oh wow. Heat map. Fascinating. What's under news? Sorry, I haven't been here in a while. I haven't like actually signed in. Look, they're still updating stuff. Okay. What? Problem 1,000 is scheduled. They're gonna hit 1,000 problems. That's awesome. Recent. Oh, most recent problems, not my most recent. Okay, I see. I see. And then yeah, archives. This is that. So you can see some of them have a little PDF icon that I can't click on. Once I successfully solve a problem, this PDF is like a generic, is like a like the official solution, even though there's lots and lots of different solutions, and you notice some of them don't actually have a solution. I'm not exactly sure why. It probably explains somewhere. But let's okay. Problem number one. This is what the next time I get on to do some Project Euler stuff, which I don't know, hopefully Wednesday. this is what we'll be working on. All right, so this is a pretty short problem. They do start off somewhat straightforward, not terribly harder than the problem 0, but they do get harder. So this one, if we list all of the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9. So 3, 6, and 9 are multiples of 3. 5 is a multiple of 5. There aren't any other multiples of 5 below 10. It's not up to 10, it's below 10. And then if we add these multiples of 3 or 5 together, we get 23. Okay, that makes sense. 8, 14, 23, yes. Find the sum of all the multiples of 3 or 5 below 1,000. So not nearly as many as before, but this would still be very time-consuming to do by hand. There's also a little, what's the word? There's something here we need to be aware of. The naive way to do this is just kind of like we did before, create two different lists. One where, like here where we went up by 2 in our range, right? We started at 1 and then went up to 2, so we get to 3 and 5 and 7. Well, for multiples of 3, you would start at 3, and then you would just add 3. So you get 3, 6, 9. So we make that list. And we also do the same thing for 5, start at 5 and go up by 5 every time, 5, 10, 15. And then we add the lists together individually, and then whatever their totals are, we add those together, and boom, we should have the list of all the multiples of 3 and all the multiples of 5 that are below 1,000. You know, we make our limit 1,000. However, if we did it that way, we'd run into a problem. Our number would be too big. You see why? Add up all the multiples of 3, add up all the multiples of 5, take those two numbers and add those together. Why would that be too big? I'm going to leave you with that. We'll talk about it next time. We'll have to talk about it in order to work through this problem. But for now, I'll leave you to think about why that straightforward, naive approach won't give us the right answer. We'll have to do something. We can do it that way partially, but we'll have to do something extra. Yeah, that's Project Euler. We're started. We are started. We finished problem 0. We're on to problem 1. I feel like that's going to be motivating for me. Makes me want to get in here. Let's say Wednesday. The problem is just like I schedule, like students will like want to schedule when I'm doing my streams because that's a time that's convenient for them. And it's really hard for me to not schedule over the tutoring sessions over the top of these streams because I feel like I'm just doing the streams for me. And it's so easy to just give up the things I'm doing for myself. That's just the thing about me. That's just like something I struggle with. But as of right now, I don't have any students scheduled for that time on Wednesday. So I might get in here and do that. I would like to. But we are at, we're a little after 11:45. I am going to get off here so I can get stuff reconfigured, get my setup changed up for tutoring, and be ready for my student at noon. This was fun. I do enjoy doing this, so I am looking forward to getting here and working on problem 1. All right, y'all, I'm gonna close this stuff down, and I will just tell you all, I hope you have a great day. I hope you have a good rest of your Sunday and the coming week starts off well for you. I'm here. Please reach out. If you're having trouble with math, if you're having trouble with school, you're having trouble with life, right? I'm out here. Be well, and I will see you hopefully Wednesday, but I will see you again soon.